What I love most about rivers is you can't step in the same river twice. The water's always changing, always flowing. But people, I guess, can't live like that. We all must pay a price. To be safe, we lose our chance of ever knowing what's around the river bend. Waiting just around the river bend. I look once more, just around the river bend, beyond the shore, where the gulls fly free. Don't know what for, but I dream the day might send just around the river bend for me.
Alright, welcome to section 8.4. Today we're going to discuss the basic trig functions that we're going to be working with for pretty much the rest of the school year, because we're going to be diving into the trig section of this pre-calc class. So taking a look at all these different triangles, we want to try to figure out trigonometric ratios. Okay, ratios meaning just comparing two things. So if you really take a look at these different triangles, hopefully we notice that all of them are right triangles. Okay, we all have that little 90-degree box, but they also all have an angle that's 31 degrees. So all of these triangles we would consider similar because they all have the same angle degrees or the angle measures, but the side lengths are different. Some are bigger than others, some are smaller than others, but they're similar because all of their angles are the same measure. So since they're similar, we can compare the lengths of their sides to each other. For instance, this side, which has a question mark, is related to its hypotenuse, as we would say, the side opposite that right angle of 70. And this ratio in this triangle should equal the same ratio in the other triangles since they're all similar. So for instance, this 30 would be related to this triangle's hypotenuse of 58. In this particular triangle, let's see, we would have this side of 33 would be related to its hypotenuse of 64, and so on and so on with the other triangles. Okay, so all of the ratios are the same, and what that allows us to do is actually solve for a missing side in a triangle. So for instance, if we were to continue this maybe over here, we would have question mark over 70 would equal whatever this fraction might be. So if you were to type in 30 over 58, I believe you get something like 0.517 maybe. So we can simply multiply the 70 over to figure out the length of this missing side. So if we did that, we'd get about 36.21. So our missing side is about 36.21 units, whatever it might be, and we kind of had to use the other triangles to help us out, but we were able to do that because all of the angles were the same measure. Okay, this is going to lead us into our trig functions because we're specifically looking at the relationships between sides in triangles. Alright, so now we're going to start talking about these trig functions. Maybe you've seen them before in geometry. Okay, hopefully you have. The three trig functions are sine, cosine, and tangent. Okay, so these are the actual formal names of the trig functions, sine, cosine, and tangent, but we abbreviate them just to save space on paper and even on our calculators. So you'll see sine written as sin, cosine represented as cos, but tangent represented as tan. Okay, so when we're talking about these trig functions, I don't want to hear you say sin, cos, or tan. Okay, that's not correct. Okay, that's not grammatically correct. So I want you to say sine, cosine, and tangent, but you can write them abbreviated if you want to, but when we're speaking about these trig functions, we're going to use the formal names. So the reason I played a little clip from Pocahontas at the beginning is because she's everyone's favorite Indian princess, but there's actually a Indian chief in math actually. His name is Chief Sokotoa, and this Chief Sokotoa, notice how his name is spelled, it helps us remember the relationships with these different trig functions. Okay, so we're going to get to why he's called Sokotoa in a second. Alright, so let's first talk about sine. Now, this little weird symbol, I don't know if you've seen that before, but this is just a Greek letter called theta. And we use Greek letters to label angles. Okay, you might see theta. This little symbol right here is alpha. This little symbol down here is beta. So you might see little Greek symbols. They're just representing angle measures. Okay, the common one is theta, but you might see some different ones as well. So we're specifically focusing on this angle in this triangle, and we're going to try to find the 3 different trig functions related to this specific angle. Notice how it's sine of that angle, cosine of that angle, and tangent of that angle. So in relation to this angle, we want to label the sides and how they are related to this angle. So for instance, we could label this side B as the opposite side because it's straight across from the angle. We can label A as the adjacent side because it's technically next to the angle. But this side of C is always called the hypotenuse because it is opposite that right angle. So we always need to be careful about which angle we're focusing on because the sides, how we label them, might change. For instance, if we were focusing on this angle up here, notice how A would be the opposite side in relation to this angle. But since we're focusing on theta, B is the opposite side for this particular angle. So what trig functions actually do is they set up these different ratios that we talked about with these different triangles in proportions with each other. So sine of a particular angle is always the opposite side over the hypotenuse. It's comparing the opposite side to the hypotenuse side. Now cosine, on the other hand, compares the adjacent side to the hypotenuse. So we would be comparing A to C. And then tangent compares the opposite to the adjacent. Okay, so we have 3 different trig functions comparing kind of all the different possibilities or combinations of these different sides. So in this particular example, the opposite side we labeled as B, and the hypotenuse was C. In this particular example, again, the adjacent side was A, and the hypotenuse was C. And for the opposite and adjacent, we would have B over A. So again, you always got to focus on which angle are you talking about and then label your sides appropriately. Let's try this first example. We're looking specifically at this angle of alpha, and based on that angle, let's label the different sides. So this 5 is the opposite. Notice here is the right angle. So the side opposite that is always the hypotenuse, and which means the 12, since it's next to the angle, is considered the adjacent side. Alright, so let's talk about chief SOHCAHTOA over here for this example. Notice how when we talk about sine, we are comparing the opposite side over the hypotenuse. Okay, so that's where the SO part is coming in. The sine, the S, is comparing opposite over hypotenuse. Now cosine is comparing the adjacent over hypotenuse. So the CA part, the CAH, is comparing cosine, is the opposite, or sorry, adjacent over hypotenuse. And then tangent, the T, is comparing opposite over adjacent. So if you can remember chief SOHCAHTOA, it's a good, easy way to remember these 3 different trig functions and what they are actually comparing. So let's talk about the sine of alpha. Sine is opposite over hypotenuse, according to chief SOHCAHTOA. So we labeled the different sides appropriately. The opposite side is 5, and the hypotenuse is 13. So we got that opposite over hypotenuse. If we check out cosine, cosine is adjacent over hypotenuse. So we would need 12 over 13. And then the tangent of alpha is the opposite over adjacent, so we would need 5 over 12. Notice how the ratio changes depending on which trig function you're actually trying to find. Alright, last but not least, let's go ahead and take a look at this one. This time we're focusing on the angle beta. So let's label our sides appropriately. 15 would be opposite. The hypotenuse is always opposite that right angle, so we can label 17 as the hypotenuse, which means 8 would be the adjacent side. So sine is opposite, which is 15, over hypotenuse of 17. Cosine is adjacent, which would be 8, over the hypotenuse of 17. And then tangent is opposite, okay, that 15, over the adjacent side of 8. So these trig functions are just ratios or ways we can compare the different sides in a right triangle. Okay, notice how they all had to be a right triangle. Alright, so now that we have a grasp on these trig functions, let's actually use them to solve missing pieces of these triangles. Let's first focus on trying to find a missing side. Okay, so we're going to figure out in this right triangle, notice how we have that little box there, what is the hypotenuse? Okay, so let's label that as hypotenuse. And we specifically know this length to be 22 and this angle to be 28. So if this is the angle we know, let's label the different sides in relation to this angle. We already labeled the hypotenuse. This side over here would be the opposite side, but notice how that's not really labeled, which means 22 would be the adjacent side. So we're dealing with an adjacent side, and we're trying to find the hypotenuse. So which trig function would we use if we're dealing with the adjacent and the hypotenuse? Okay, think of Chief SOHCAHTOA. Well, that would be the cosine. Okay, so we would need to take the cosine of the particular angle we're focusing on, which is 28, and this should equal the adjacent side of 22 over the hypotenuse of x. Now what's nice about this is that we can actually type in the cosine of 28 into our calculator and see what we get, but we got to be careful that our calculator is set on the degree mode. So let's see, to check that you can hit the mode button, and it should be in the third row right here. Notice how it says degree. Okay, mine's already selected, so you may have to change yours, but since we're talking about 28 degrees, we should be in degree mode. So let's go ahead and type in the cosine of 28. All trig functions are easy access on your calculator right in a row. So we're going to type cosine of 28. And we get about 0.88, we'll say. Okay, so 0.88 equals 22 over x. And now it's just simply figuring out what x is. Okay, we can think about 0.88 as over 1 and maybe cross multiply to figure out what x is. So we get 0.88x would equal 1 times 22, which is just 22. And lastly, dividing by 0.88, we should get something roughly about 24.92 perhaps. All right, so the length of this hypotenuse is 24.92. Now on the other side, instead of finding a missing side, we can actually figure out a missing angle. Again, we're still going to use those trig functions to help us out. We're trying to figure out this particular angle, what's that degree measure. So in relation to this angle, let's label the sides we know. 12 would be the opposite side. And notice how 20 is opposite that right angle, so this would be the hypotenuse. So which trig function involves opposite and hypotenuse? Think of Chief SOHCAHTOA. Well, that would be sine. So we're going to try to figure out sine of this angle, which is x, and that should equal the opposite side of 12 over 20. Now here's the thing, we want to figure out what x is, which means we got to move sine to the other side. And in order to do that, normally we're dealing with inverse operations. For instance, if you were adding something over here, you'd have to subtract it over. You got to do that opposite. Now in terms of trig functions, we do have an inverse option. If you want to move sine to the other side, we need to use the inverse of sine, meaning sine to the little -1 power. So we got to move the sine to the other side, so we're left with sine to the -1st of 12 over 20. And we do have an option to solve this on our calculator. Notice how directly above your trig functions, sine, cosine, and tangent, you have the little inverses above them in blue. So we need to select the blue button first and then hit the sine as our option, because we want to find the inverse sine of 12 over 20, which is going to give us about 36.87, we'll say. So this particular angle we're finding is 36.87. Again, we're using trig functions and the relationships between the sides to help us solve for missing pieces. So if we can figure out a missing side with trig, and we can find a missing angle with trig, we could probably solve any piece of any triangle we would want to using these trig functions. So when it's asking us to completely solve this triangle, we want to find all angles and sides. So let's do that for this one. Find all angles and sides. So maybe I'll label this side as x, we'll label this side as y, and we'll label this missing angle as theta. Okay, we want to figure out all these missing pieces. So let's see where we can start first. Okay, well, maybe the angle might be easier because we already know what two of these angles are. Hopefully we remember from geometry that there are 180 degrees total in a triangle. So if this one's 90 and this one's 62, we can figure out what theta is. Because if we take 62 plus 90 plus theta, we should get 180 degrees. So maybe moving over the 62 and the 90, our angle for theta is going to be 28 degrees. Alright, so that one's not too bad. But now let's try to figure out these missing sides. Alright, so you can pick in any angle you want except for the right angle, because the right angle is special. We can either pick angle 62, or now that we know what theta is, we can use 28 if you want to. It does not matter. Maybe I'll stick with 62 just because that's the one they initially gave us. So let's maybe figure out what x is first. In relation to 62, let's label all the sides. Y would be considered the opposite. 12 is opposite the hypotenuse, or sorry, the opposite the right angle, so it's considered the hypotenuse, which means x is the adjacent side. So let's focus on finding x first. If we're finding x, we want to find the adjacent side, and notice how we know something about the hypotenuse. So which trig function, think of SOHCAHTOA, involves the adjacent side and the hypotenuse? Well, that would be cosine. So we're dealing with cosine of this particular angle 62 we're focusing on, and that should equal our adjacent side x over the hypotenuse of 12. Now to get x all by itself, we can multiply the 12 over, which would give us 12 cosine of 62. And from there it's just calculator work. We can type in 12 cosine of 62, and we get about 5.63 it looks like. So the side length of x is 5.63. But now let's try to find y. Again, we can focus on this angle. Notice how y is the opposite side, and we knew something about the hypotenuse. So which trig function involves the opposite in the hypotenuse? That would be sine. So we can say sine of 62 equals the hypotenuse, or sorry, the opposite side y over the hypotenuse of 12. Again, to solve for y, we can multiply the 12 over, and from there we just have a little bit more calculator work. So let's type in 12, and this time sine of 62, and we get, looks like 10.6 maybe? So y equals 10.6. So using some trig, we can figure out all of these different missing pieces. Alright, so when it comes talking about these different trig functions, there's two big ideas. One of them is called the angle of elevation, and the second one is the angle of depression. Okay, they're a little bit different, and we're going to just discuss both of them briefly, because I think we're going to be pretty good with these. Angle of elevation is pretty simple. Okay, elevation just meaning kind of a height, and notice how we're always going to be kind of talking about a horizontal position, almost like a ground level, and then something is going to be taking off or growing or flying or something to that effect. So this right here would be considered the angle of elevation. It's the angle that's made between the horizontal line, whatever that might be, okay, usually it's the ground, and then the path an object takes lifting off at some point. So that's our angle of elevation. So let's take a look at an example of what this actually looks like. An airplane takes off with an angle of elevation and raises to an altitude, or a height rather, of 1,500 feet. We want to figure out how far is the plane from the airport via the ground distance. So let's take a little picture of that. Maybe we'll say it has an angle of elevation of 12 degrees, just as an example. So we have a runway, which is basically the ground, and the airplane is taking off. Maybe we'll draw a little airplane. Okay, that's the best I'm gonna do, guys. And the angle of elevation between the ground and the airplane is 12 degrees. And we know something about the altitude, or the height. Okay, the height of the airplane, they told us it's 1,500 feet. So we want to figure out how far is the plane from the airport. Okay, here's our little airport. Via the ground distance. So we want to figure out what is this distance here from the airport to where the airplane is currently. So notice how we have an angle and we're trying to find a missing side. Clearly this is a right triangle because the height is perpendicular with the ground. It's forming that 90-degree angle. So let's go ahead and use some trig. In relation to this angle that we know, we can label the sides. 1,500 would be considered the opposite side, and then the side of x is the adjacent, because notice how the hypotenuse was not labeled. So what trig function involves the opposite and the adjacent sides? That would be tangent. So tangent of our angle 12 should equal opposite over adjacent, or in other words, 1,500 over x. So what we can do is maybe multiply the x over to get x tangent of 12. And to figure out what x is, we can divide both sides by tangent of 12. Because after all, this tangent of 12 is actually a number. Okay, we're going to use our calculator to figure that out. So let's go ahead and figure out the distance from the airport that our airplane is. So we can do 1,500 divided by the tangent of 12. And it looks like we have a distance of 7,056.95 feet. So there are going to be some word problems that you're going to have to do, especially with this idea of angle of elevation and angle of depression. I highly suggest drawing a picture just to have a visual for you. Okay, it should be really easy for you to label the different sides and the angles you have. Okay, a picture always helps. Alright, so next we're going to talk about angle of depression. Very similar to angle elevation, but instead of rising from a horizontal position, this one is going to decrease or fall. So maybe we have this horizontal line that we're dealing with. Usually it's a line of sight, like how well, maybe I'll just draw a picture. It's the line of sight you see, and then the angle of depression is the angle that's going downward. So normally you look straight across, but if you're looking down at an object, maybe like a flower or something going on down there, this would be the angle of depression. Okay, what angle you have to actually look down at something. So Mr. Parks looks out his window with an angle of depression of 32 degrees and sees two kids fighting. He decides to break up the fight if it is less than 50 meters away. I guess he decides he can make it there in time if it's less than 50 meters away. If his window is 28 meters from the ground, will he break up the fight? Okay, again, let's take a picture, or let's draw a picture to kind of visualize this. We'll say this is his window, and we got the ground. Normally, okay, so Mr. Parks is looking out his window. Normally when you look out your window, you look straight across. But he's actually, it tells us he's looking down, or an angle of depression, at two kids fighting. So maybe the two kids are right here somewhere. So this would be considered the angle of depression. So we can label this as 32 degrees. And then it told us that, let's see, if his window is 28 meters from the ground. So this distance here is 28 meters. Alright, so let's take a look at this. What we can do with these angle of depressions is kind of form another triangle to help us, because we know this distance is 28, and this is the angle we're focusing on. But if this distance is 28, that means this distance is 28 as well. And if we're trying to figure out how far he is away from the children, we're trying to figure out this ground distance, but notice how this ground distance is the same distance formed up here. So we're kind of almost making a rectangle out of this angle of depression and the regular triangle that's formed with his window and the ground. So we know this angle is 32, we know this side is 28. Clearly this is our right angle forming by a horizontal and a vertical distance, and we're trying to figure out this length of x. Is it 50 meters away? Is it more, or is it less? What's going on here? So in relation to this angle of 32, let's label the sides we know. 28 is the opposite side The hypotenuse is not labeled. That's kind of his line of sight here as he's looking downward, which means that this side of x is the adjacent side. So if we know something about the adjacent side and the opposite side, which trig function would we be using? Well, that would be tangent again, opposite over adjacent. So tangent of 32 would equal the opposite side of 28 over the adjacent side of x. Again, we can move the x over by multiplying. And to get x by itself, we can divide by the tangent of 32. So just some calculator work. Let's see, we got 28 divided by tangent of 32. And we get about 44.81, we'll say. So 44.81 meters. So let's answer this question. If his window is 28 meters from the ground, will he break up the fight? Well, it said he decides to break up the fight if it is less than 50 meters away. Last I checked, 44.81 meters is less than 50, so yes, he would be able to break up that fight. Alright, so again, drawing a picture absolutely helps with these. Good luck on the practice and the application in that mastery check, and I'll see you guys later.